what do you know about isosceles triangles? Do you know what the definition of an isosceles triangle is? That's equilateral, but it can be all three. It has to be at least how many? 2, right? So an isosceles triangle is technically 2 or more sides that are congruent in a triangle. The or more part we don't really focus on because when we talk more, we're talking about equilaterals. So we're just going to focus on an isosceles triangle as 2 congruent sides, okay? So here are the different parts to an isosceles triangle so that you can identify what needs identifying. If those are our 2 congruent sides, we call those our legs. And then the other side, which is not always the bottom. People always hear the word base and they think bottom. The base does not have to be the bottom of the triangle. It just has to be the one that is not one of the 2 congruent sides. Okay, so that is our base. But then we have a vertex angle and base angles. The vertex angle is always the one where your 2 legs meet up. And then the base angles are the 2 angles that are touching the base of the triangle. So these 2 are base angles. And then your 2 legs and the vertex and the base. Okay, so that's the parts of an isosceles triangle that you're going to be using a lot in the next couple lessons here. There are 2 theorems, the original and the converse of the isosceles triangle theorem. And the original says this: if 2 sides of a triangle are congruent, so in other words, if a triangle is an isosceles triangle, then the angles opposite those sides are also congruent. So in other words, in this picture, what it's saying is because I know AB is congruent to BC, then I also know the angles across from those sides, so these 2 angles would have to be congruent, okay? So basically it's saying if AB is congruent to BC, then angle A will be congruent to angle C, okay? So because we know it's isosceles, we also know those base angles have to be the same, okay? Base angles are congruent. Then there's this here's why, okay? This is just me proving to you why the isosceles triangle theorem works. Here's what happens with this. If I draw in an angle bisector here, so that those 2 angles are the same, and it is an isosceles triangle, which means these 2 sides are the same, that bisector, this line right here, is also reflexive if we think of it as 2 separate triangles, right? So I know that this side is congruent to itself. You could call it BD if we label that a D. So if that's the setup of these 2 triangles, I know right now that triangle ABD is congruent to triangle CBD by what? What do you see in those markings? That's SAS, right? So we know the triangles are congruent by SAS. So in order for us to know that angle A and angle C are congruent, these 2 angles here, we would say angle A is congruent to angle C by what? If you know the triangles are congruent, then you know everything about them is congruent. What is that? That's CPCTC. Okay, so this is the reason that the isosceles triangle theorem exists. This is the proof of why we can do it, okay? Okay, then there is the converse of that theorem. Let me get this out of here. And you know what a converse does, right? Just takes your if-then statement and reverses it. So your if becomes your then and your then becomes your if, or your hypothesis and conclusion switch places. So this one would say if 2 angles of a triangle are congruent, then the sides opposite them are also congruent. So now in this case, it's just the reverse. This one's saying if angle A is congruent to angle C, then we know this side across from C and this side across from A would have to be congruent. So then AB is congruent to BC. Okay? Any questions on that? All right. So those are the theorems. Look at this example, example 1 here, and let's see just based on those theorems if you can figure out if these statements are true. So the first thing says, is Gk congruent to Hk? So they're asking us, is this segment congruent to that segment? Do you think yes or no? Based on the markings they give you. Evan's nodding, Harrison's nodding, Lauren's nodding. Why? Why would those be congruent? Isosceles triangle theorem, right? It's the converse of the isosceles triangle. So we would say, oops, let's not make a highlighter. Are they congruent? We would say yes, because their base angles are congruent, so the opposite sides have to be. In other words, you could just say yes by the converse of the isosceles triangles theorem. Okay? So those would be congruent. This segment would be congruent to that one. All right. Second question, is HL congruent to KJ? Based on the markings they give you, are those congruent? Notice what the markings are doing here. The angles that we know are congruent are all on this side, right? So this would be the base of my triangle, which means the sides that would be congruent would be these two sides here, right? This side would be congruent to that side as a big figure. They're giving us this and this, which is not even part of the triangles that would even have to be congruent based on our angles, right? So in this case, when it asks you, is HL congruent to KJ? We don't know, but we're just gonna say not necessarily, because they could be. We don't really have enough information to say they are or they are not, but not necessarily because they're not corresponding parts of isosceles triangles. Okay, does that make sense? So look for what angles they give you to be able to tell what sides then match up. There's a couple of problems, I think it's like 6 and 8, maybe 10 in your homework, where you really got to think through it. Like, here's what I know, that leads me to this, which leads me to this, which leads me to, are they congruent? You have to see if you can figure those out. Okay, last theorem, and then we're done. One example with this theorem. The theorem says this, and you don't need to memorize the 4, 5, I don't care about the number, but what it says is if a line bisects the vertex angle of an isosceles triangle, then it's also, this should be an N, sorry, then, oh, and my it is backwards, struggling. Then it is also the perpendicular bisector of the base. Okay, so here's what this is saying. If I were to draw in the bisector of angle B up here, so my vertex angle, if I cut it in half like that, this looks just like what I showed you earlier, the proof of why the isosceles triangle theorem worked, right? What they're saying is this then has to be perpendicular, and this bottom piece is going to get bisected. So it's a perpendicular bisector of AC, okay? Why that's helpful is you will get pictures that look like this. They tell you that these are congruent, okay? And and we're going to try to find angle X. Now, here's the deal. You can do this two different ways. Is that a hand up right now?
Yeah.
Yeah, what's up?
Is it homework on paper or is it offline?
It's so good to have you here. I'll tell you in a minute. Okay, so if this is your setup, right, you have these congruent, you have the bisector here. One of the ways you could do this, does anyone see it? Okay, so one way you could do this, because this is isosceles, this is 61 and 61, right? That makes this angle up here x also. So if you just look at it as a big triangle, you have 2x plus 61 equals 180. This isn't the way I would do it just because it's bigger numbers and it's more work. It's not more work. It's maybe more work. But you can totally do it this way and you will get the right answer. Do you see the other way? There we go. Right, so if this is a bisector of this angle up here, then it's the perpendicular bisector of the bottom one, right? So this is 90. These are congruent. That means if I'm looking at just the one triangle, right? If we just look at this triangle then, you have 90, 61, should have changed my pen, and x, that will add up to 180. Let's try that again. So 90 plus 61 plus x has to equal 180, and then just take away that 151. So x would be 29 degrees. So regardless, if you did it this way, it's not wrong. It's just slightly longer, slightly more work. But you can look at it as this is 90. Therefore, the smaller triangle, 90, 61, and x will add up to 180. Okay? Questions on that? Adam, your homework is out of the book today.